Today we're going to look at parent functions part 1, specifically 3 parent functions. The first parent function is y equals x. The second parent function is y equals x squared. And the third parent function is y equals x cubed. So what we're going to look at is how to identify what the parent function is based on either an equation or a graph. Okay? So the first one we'll start with is y equals x. So when I deal with y equals x, more often than not, the way that you would see this represented is actually kind of in slope-intercept form, where it has y equals mx plus b. One of the big giveaways is that x has a power of 1. Notice in this form, x has a power of 1. All right, so as long as x has a power of 1, then I know the parent function is y equals mx. There's a couple ways we could see this. We could have y equals 2x, y equals 1/2 x minus 3. But notice that y equals something x. X still only has a power of 1, so that means its parent function is y equals x. We also have this one. X has a power of 1, so its parent function is still y equals x. Now, if y equals mx plus b is the standard form, that means that my graph is linear. All right, so if I was to do y equals x, it should be a line. All right, so if I do y equals 2x or y equals 1/2 x minus 3, it's going to be this turned or shifted in some form or fashion. All right, so let's look at y equals 1/2 x. All right, so it has a slope of positive 1/2, but then it has a y-intercept of -3. So there's my y-intercept, and it has a slope of 1/2. So rise over run, so up 1 over 2, up 1 over 2, down 1 left 2, down 1 left 2. So notice this is still a line, but it just has been shifted in some form or fashion. All right, so if I look at this, I know that this one has a parent function of y equals x, and this one has a parent function of y equals x because they're both linear graphs, so therefore their parent function is y equals x. So what we're looking at is how to identify. If x has a power of 1, its parent function is y equals x. If the graph is a line and has no breaks, no curves, then its parent function is y equals x. The next one we're going to look at is y equals x squared. There's kind of 2 ways you can see this. One that actually shows me a vertical shift or horizontal shift, and the other one is in standard form. So standard form of a quadratic is ax squared plus bx plus c. So when I look at this, this is the standard form of a quadratic. The highest power of x is 2, so this has a degree of 2. So since the highest power of x is x squared, then I know the parent function is y equals x squared. So any way I write this with whatever number a, b, or c is, since x has a power of 2, and that's the highest power, then the parent function is y equals x squared. Another way we could see this is written as y equals, we could say x minus 2 parentheses squared plus 4. So when I look at this, this would be my horizontal shift, vertical shift. Okay, this is vertex form. All right, so if I look at it, the x is grouped inside the parentheses and the parentheses is squared. So this is like saying x squared. All right, if I FOIL this out, it's going to give me standard form. All right, so the 2 ways I could have this presented is vertex form or standard form. And so if x is squared, we have y equals x squared. X parentheses squared, y equals x squared. Now, the graph of x squared is a little bit, or is pretty easy to identify, all right? We know that it's a parabola, okay? The parabola could go up, or the parabola could go down, all right? All this means is that my leading coefficient is negative, or this one's positive, my leading coefficient's negative, but this would still be a parent function of y equals x squared. So, vertex form, standard form, the power of x is 2, the power of x is 2. all right, a U shape and a U shape. That would give me a parent function of y equals x squared.
Some people pick their nose, but I was born with mine.
So the last we're going to look at is y equals x cubed. It's going to be very similar to how the y equals x squared looked. All right, we have standard form of a cubic function, which is y equals ax cubed plus bx squared plus cx plus d, where a, b, c, and d are some numbers. But notice once again, the highest power of x is 3. So the highest power is x cubed, so my parent function is x cubed. The other way it could be written is just like we had with the quadratic, which for the quadratic was vertex form, but this, it's not really vertex form, it just shows a vertical and horizontal shift. So we could have y equals parentheses x minus 2 cubed plus 4. So now, notice once again, the x is grouped inside of a parentheses, and the cube is on the parentheses. So if I were to multiply this out, it would give me the standard form of a cubic. All right, so these are two examples of how it could be presented. All right, both of these are representations of this parent function that has been shifted in some form or fashion. A lot of the ones we'll look at in terms of identifying a horizontal and vertical shift for my graph is going to look kind of like this. If I'm trying to identify it, we're probably going to end up using my standard form. We're probably going to use Desmos. All right, but all we're doing today is trying to figure out which parent function it is. So the highest power of x is cubed, so my parent function is y equals x cubed. And since this is grouped x minus 2 inside of parentheses and it's cubed, I know that it is y equals x cubed. Now, the graph of a cube function looks like this. So this is just a generalization, it's not perfect, but if I see a graph that looks like this, where it starts down and goes up and it's like this, that would be a positive y equals x squared. All right, negative would be the reverse. All right, so that just means my leading coefficient is negative. All right, so this is the generalization of what the graph would look like. If you were to type it in the Desmos, either one of those, and it looked like this, you would automatically know that the parent function is y equals x cubed. Once again, I could have it in this form, which shows me my vertical shift and horizontal shift, or I could have it in this form, which is standard form. All right, so as I said, we're trying to identify based on the graph or an equation which parent function it is.